Hello, this is Mr. Collier, and today we're doing the inverse normal distribution. Okay, so we're going to be basically be given probabilities, and we're going to be finding values or x values on the curve. Okay, so let's draw a sketch of the first situation here. We have a normal distribution with a mean of 12 and a standard deviation of 9. Probability x less than k is 0.8, so it's going to be way over here. So this area is 0.8 and this area is 0.2. Okay, so we're going to find the k value by using our calculator to find out this value right here. So obviously it should be a bit more than 12. So let's open up the calculator and let's go to Toolbox. Toolbox, probability, and we go down to an inverse here, inverse normal, and you type in the mean, comma, standard deviation, which is actually 3, I made a mistake earlier, square root of 9, which is 3, comma, 0.8, right? And then we get, this spits out the k value, which is 14.5. Okay, that makes sense. It should be a bit more than 12. So k equals 14.5. The next one we got probability k is, x is greater than k is 0.65. So it's going to be to the left of the mean, because this is 0.65. But that means this part is 0.35. Okay, so most calculators you will need to look at probability x is less than k rather than greater than k. Okay, so that's 0.35. So we type that into our calculator. Let's copy and paste that one. And let's just type in 0.35. And that gives us 10.8. So k is about 10.8, which makes sense because it's a little bit less than 12, right? Okay, the next one, z kind of implies the standard normal distribution with a mean of 0 and a standard deviation of 1. So that one we have 0 in the center. Probability z is less than k is 0.2, so k is probably over here somewhere. And this is 0.2, right? So on the calculator, now if you don't type in the mean and standard deviation, it takes it to be the standard normal distribution. So you can just take this and just type in one number. You can just type in 0.2 and it'll give you that. So it's negative 0.842. K is negative 0.842. Okay, next, greater than 0.3. So greater than k is 0.3. So this is 0.3 and this is 0.7. So we're looking at probability z less than 0.7 equals 0.3. Less than k is 0.7. Okay, and we solve that for k. We just type in this again, copy that, type in 0.7, and we get our answer. 0.524. 0.524. Okay, and lastly, this probability, let's check it out on the graph. So we've got zeros in the middle. Actually, maybe we don't know if it's to the left or right of the middle, but let's just put k here somewhere. And between k and 0.6 we know is over here. It's to the right of the mean. So saying this area here is 0.2. But to get that area, you basically take the entire area up to 0.6, and then you subtract the area up to k, right? And that will give you this area right here. So basically this is the equivalent of saying probability z less than 0.6 minus probability of z less than k has to be 0.2. Okay, we subtract those probabilities to get this region right here. Basically, we subtract those areas to get the area of this region right here. I'm going to rearrange this. This is just a number we can get on our calculator. We're solving for this one here. So I'm going to rearrange this to get probably z less than k equals probability z less than 0.6 minus 0.2. Okay, let's work that out on our calculator. That is, let's go to toolbox, probability. This is not an inverse, this is a regular cumulative probability right here, right? So cumulative normal, and we just need to type in 0.6. That gives us that number. Let's subtract 0.2, and we get 0.526. Okay, so probability z less than k is that, and now we just do inverse normal to get the k value. So we're going to do inverse normal, and I will delete that and copy this answer here. Close my bracket. Hope that didn't quite work. Okay, there we go. So it's 0.0646. Okay, next we have this example. The waiting time at a doctor's surgery is normally distributed with a mean of 10, a standard deviation of 2.5. So x has a normal distribution of 10 and 2.5 squared. And we're saying the probability x is less than k equals 0.95. So we just do inverse normal on our calculator to get that value. Okay, so let's do this one. Let's copy that one and change this to a 10, comma 2.5, comma 0.95. We get 14.1. Okay, 14.1. And okay, next example. Okay, next example we have x has a known standard deviation of 2. It's also known that probability x is greater than 23 is 0.6. Find the mean. So what we can do is we can take this, let's draw this. So we don't know the mean, but probability x is greater than that is 0.6, so x should be right, or 23 should be right here, right? And we don't know what the mean is. It's bigger than 23 though. This is 0.4 because that's 0.6, right? This area is 0.4. What we do to solve this problem is we find out basically how many standard deviations this value is away from the, or 23 is away from the mean, which is basically finding the z-score. This is the normal, standard normal distribution. Okay, it looks like it's going to be, z is going to be like negative 0.5 or 6 or something. Okay, so we want to get that corresponding value right there. Okay, so what we do is we use the z-score formula. Z equals x minus mu over sigma. Okay, and what we're going to do with this is we're going to change that to x minus mu, which we don't know. Actually, we know the x value, so let's just put that in. The particular x value we're talking about is 23. 23 minus mu over sigma, which is 2, should be equal to the z-score at, or the z-score that gives me 0.4. Okay? Okay, this corresponding z-score for 0.4, or the z-score that gives me a probability of 0.4. So to get that value, we just go to normal, or inverse normal. We need the inverse normal for 0.4. And we get negative, so that's negative 0.253. That's 23 minus mu over 2. Okay, solving for mu, we simply take that number and multiply by 2. Then we will subtract 23. That'll give you negative mu, so mu is 23.5. Mu is approximately 23.5. which makes sense. The mu should be a little bit bigger than 23, right? So mu is actually 23.5. Let's take a look at another example. In this question, we have to find the mean and the standard deviation, so two of them. Firstly, let's rewrite this as probability x is less than 35 equals 0.68. So most calculators use cumulative distribution functions, so you need less than here. Okay, we need these both to be less than. Okay, so now we use the formula like we did before. We take the x value minus mu over sigma equals the z-score associated with the probability of 0.68. And here the x value is 8. 8 minus mu over sigma equals the z-score that gives me a probability of 0.26. Okay, so let's find those numbers in our calculator. We can go to, again, this function right here. We type in 0.68. And we get 0.467. We want a lot of digits to be more accurate in our answer later. So let's write them all out. So 35 minus mu over sigma equals that. And for the other one, let's copy and paste that. And what was it again? 0.26. And we get negative 0.643. 8 minus mu over sigma approximately equals negative 0.643. Okay, these are two simultaneous equations, and we're going to solve it with our calculator in a second. We just need to rearrange so that we can type it into our calculator. Let's rearrange this to 35 equals, we can bring the mu to the other side and after, well, multiplying by sigma. So multiply this by sigma and then add mu and we get this. Okay, that's one of our equations that we're going to use to solve, and then this means 8 equals mu minus 0.6. Oh, why didn't I get more digits? 3, 3, 4, 5, 4, 1, sigma. That's our second equation. We just type those into the equation solver on our calculator, and we can get the answers. That's a sigma there, sorry. Okay, so let's go to apps. Linear solver. Make sure you're on 2 by 2, and x and y will become mu and sigma. So you can just type in a 1 and 0.46769988. And this one's 35. The second one, you always get 1 for your mu's. And then here we get negative 0.643345. 4, 1, and 8. So that gives you the x and y value here, the mu and the sigma. So mu is 23.6, and sigma is 24.3.